Right now, astronomers have cataloged 8 planets, roughly 4,000 comets, and over 1 million asteroids in our solar system. But one object with a fascinating name, Oumuamua, stands apart from everything else. This elongated, flattened astronomical body was spotted 5 years ago and is currently racing away from our solar system. What makes it truly extraordinary? It's the first confirmed celestial object to visit us from another star system, from an unknown world beyond our own. For years now, astronomers have been locked in debate. Is this exotic visitor a comet, an asteroid, or something else entirely? Some of its characteristics are so bizarre that even the possibility of an alien spacecraft has been seriously discussed by respected scientists. So what exactly is Oumuamua? The Oumuamua mystery began in Hawaii, where Robert Warwick, an astronomer at the University of Hawaii, stumbled upon this object by chance. On October 19, 2017, he was using a telescope called Pan-STARRS, designed to scan the skies for potentially hazardous asteroids that could threaten Earth. When Warwick noticed a new object, he immediately checked observation data from previous nights and combined the results to calculate the body's orbit. That's when things got really interesting. The trajectory was unlike anything they'd seen before. After additional observations, Warwick and his colleague Marco Micheli reached a stunning conclusion. This object's path indicated it came from beyond our solar system. This was nothing short of a historic discovery, the first time astronomers had observed an interstellar object passing through our cosmic neighborhood. But here's the thing, it wouldn't be the last. Astronomers had long predicted that interstellar objects would eventually show up in their field of view. Yet somehow, until 2017, no one had spotted a single one. Initially, the cosmic visitor was officially catalogued with a rather technical designation, but a historic find. Like this clearly deserved a more memorable name. They chose the Hawaiian word Oumuamua, which roughly translates to scout from a distant place arriving first. Oumuamua first caught astronomers' attention as it whipped past the sun at an extraordinary velocity, approximately 54 miles per second. To put that in perspective, that's far faster than objects native to our solar system, which typically cruise at around 12 miles per second. This incredible speed was the first major clue that we were dealing with an interstellar traveler. The trajectory sealed the deal. By the time astronomers spotted Oumuamua, it was already a month past its closest approach to the sun. Essentially, it was already on its way out. The object had shot across the plane of the planets at a steep angle, moving fast enough to completely escape the sun's gravitational pull. In other words, our interstellar visitor didn't settle into orbit around our star. Instead, it made a sharp turn and headed straight for the outer edges of the solar system. We'll never see it again. Astronomers rushed to observe Oumuamua using various ground-based and space telescopes. Unfortunately, given the object's speed and size, they had precious little time before it became too small and faint to study. Despite their best efforts, Oumuamua passed too far from Earth to appear as anything more than a dot of light even through the most powerful telescopes. But that tiny dot revealed something astonishing. By combining observations from multiple telescopes, scientists discovered that its brightness fluctuated wildly, changing by a factor of 10. No known asteroid or comet from our solar system varies in brightness anywhere near that much. This could only mean one thing. The newcomer had an extremely unusual shape. It's likely highly elongated. Its length is probably about 10 times greater than its width, with a complex, possibly flattened shape. For comparison, the most elongated objects we've observed to date have lengths only about 3 times their width. Yet no one can say for certain what Oumuamua's exact dimensions are. NASA's article states that the first interstellar object is somewhere around 1,300 feet long and consequently about 130 feet wide. Despite the countless realistic illustrations of Oumuamua you may have seen, including in this video, astronomers have absolutely no idea what it actually looks like up close. Its elongated shape is pretty much the only thing most researchers agree on. And by the way, this characteristic poses a serious challenge to current models of how celestial bodies form. The prevailing theory suggests that small bodies in the solar system formed through collisions and accretion. But a long, narrow object would be vulnerable to breaking into smaller pieces if it existed in an environment with many other rocky objects constantly colliding with each other. But the shape isn't the only thing baffling astronomers worldwide. This enigmatic object presented an even greater puzzle as it departed our solar system. As Oumuamua moved away from the Sun, it actually began to accelerate, and with each passing day, it sped up more and more. Obviously, this was weird for an object initially thought to be an asteroid, even one with an unusual shape. On the other hand, it's not at all weird for a comet-like object. When a comet is heated by solar radiation, jets of gas can erupt from its surface, altering the body's trajectory. It's like a natural rocket engine forming in space. So naturally, something similar could have caused Oumuamua to pick up speed as it approached the Sun and heated up. This really is the most logical explanation, but there's a catch. The celestial body showed no sign of a tail or the gas cloud that forms around a comet's nucleus, so it couldn't be classified as a comet. Astronomers simply saw no evidence of such activity. So wait, could Oumuamua actually be an alien spacecraft? Avi Loeb, a renowned theoretical physicist from Harvard University, wrote a book titled Extraterrestrial: The First Sign of Intelligent Life Beyond Earth, which quickly became a bestseller. Loeb argued that Oumuamua could reasonably be considered a probable alien spacecraft. He sharply criticized the astronomical community for not thinking outside the box about extraterrestrial life. According to him, the object's shape could very well match that of a solar sail, a spacecraft that accelerates using the pressure of starlight. Of course, most astronomers dismissed this possibility. Nevertheless, many people were inspired by the idea and even attempted to detect radio signals from Oumuamua. No luck there. So what exactly is this thing? In the years since the initial discovery, only 3 other interstellar visitors have been detected. 2 of them were meteors that arrived in 2014 and 2017. It wasn't until 2022 that scientists could confirm they truly had interstellar origins based on the speeds at which they entered our planet's atmosphere. The second object similar to Oumuamua that astronomers could observe and study was the interstellar comet Borisov. Scientists had zero problems with this celestial body because it genuinely looked and behaved like any other comet. Researchers easily hypothesized its origin and how it reached us. We know that during the formation of our solar system, many icy bodies similar to Comet Borisov were ejected into interstellar space. The mechanism believed responsible for expelling these small bodies is the migration of large planets. Long ago, Neptune likely migrated to the outer solar system, to where it currently resides. And naturally, along the way, it encountered many small icy bodies that were scattered in all directions due to the planet's immense gravity. Some icy bodies may have been flung completely out of the solar system. Comet Borisov probably met a similar fate and once left its home star system before visiting us. This scenario beautifully explains the origin of ordinary interstellar comets like Borisov. But Oumuamua is anything but ordinary. Nothing remotely like it has ever been observed, and debates about its origin continue to this day. According to one popular theory, Oumuamua is indeed a comet, just a highly unusual one. It may be partially or entirely composed of molecular hydrogen in solid form. This would explain Oumuamua's strange acceleration, since the outgassing of hydrogen from the object's surface wouldn't be visible from Earth, meaning it wouldn't leave behind a visible tail like a regular comet. The only place where such a hydrogen iceberg could form would be the cold core of a dense molecular gas cloud. These are the same clouds that, when gravitationally disturbed, become stellar nurseries. Before forming into giant hot plasma spheres, molecular clouds are extremely cold inside because ultraviolet radiation from stars can't penetrate the center of dark, opaque clouds. Incidentally, these cores are also the densest regions of interstellar space. It's theorized that Oumuamua could have formed in such a place. Initially, it may have been much larger in size, but during its journey through space, it could have been heated by stellar radiation and gradually shrunk, losing material through hydrogen sublimation. This explains its odd shape, like a bar of soap that starts as a big, thick block, but after long use becomes a thin, flattened sliver. One piece of evidence supporting this idea is Oumuamua's path through space before it arrived in our solar system. Astronomers tried to trace its route backward and found that 45 million years ago, Oumuamua could have been in the same location as a molecular cloud. But the main problem with the hydrogen iceberg hypothesis is the short lifespan of such an object. Even starlight in the coldest parts of space would heat a solid chunk of hydrogen enough that a similar object simply wouldn't survive the journey from a molecular cloud to us. It would completely sublimate into a gaseous state. It couldn't wander for hundreds of millions of years without breaking apart due to stellar radiation. Hydrogen icebergs likely don't last that long in the galaxy. Moreover, it's unclear how often the necessary conditions arise within cold molecular clouds to create such objects. However, inspired by the idea of a wandering hydrogen iceberg, another group of astronomers attempted to investigate other types of ice that could withstand criticism about a long journey. These astronomers proposed that Oumuamua was actually a fragment of a distant planet belonging to another star system. Long ago, a collision between a large asteroid and a planet could have broken it off from the planet and sent it on a journey through interstellar space. The study's authors rightly note that we've never before seen hydrogen ice in nature. However, we have seen a world covered with nitrogen glaciers, just once. This happened in 2015 when the New Horizons spacecraft flew past the previously unexplored Pluto system. Oumuamua was remarkably shiny when passing through the solar system. Just as shiny are the surfaces of Pluto and Neptune's moon Triton, which are covered precisely with nitrogen ice. So the idea is that newborn Oumuamua was knocked off a Pluto-like object orbiting a distant star approximately 500 million years ago. The interstellar object's reddish color also supports this theory. According to this model, by the time it entered the solar system, around 1995, Oumuamua had already lost half its original mass through nitrogen sublimation and cosmic ray impacts. But during its passage around the Sun, it heated up so much that it melted like soap and may now constitute only 10% of its initial mass. The sublimation of nitrogen also caused it to accelerate like a rocket. Since nitrogen sublimates at a temperature of about -415 degrees Fahrenheit, and Oumuamua could have heated up to around -370 degrees Fahrenheit when passing the Sun. So it was sublimating like crazy. However, this hypothesis is also frequently criticized. Pure chunks of nitrogen are very rare on Pluto and in the universe overall. Moreover, there's a statistics problem. Given that the Pan-STARRS project detected one such object only 9 years after starting operations, this could mean that nitrogen icebergs are very common in the universe. But how? Our galaxy is unlikely capable of producing that many exoplutos. Of course, we can't rule out that we simply got lucky and Oumuamua appeared at the right time in the right place. Who knows? Either way, Oumuamua, Comet Borisov, and the 2 meteors are all the interstellar objects detected to date. However, astronomers believe there could be trillions of similar cosmic tourists out there. It's entirely possible they've been passing by us the whole time, but were so fast and dim that we simply never noticed them. Thanks to everyone who remembers to like my videos and leave comments. That's all for today.